Hello students, welcome to our student support program for Mathematics Grade 9. Our topic for today is patterns and sequences, the second lesson on patterns and sequences. In today's lesson, you will learn how to extend given patterns and figures and how to find the general term of a given sequence. So, the first part will be number patterns from patterns of figures. Let us have a look at this example. You can see 3 different diagrams, pattern 1, pattern 2, pattern 3. The first part, you are asked to draw pattern 4, and in the second part, consider the above 3 figures. How many sticks are there in patterns 4 and 5? So what can you observe from the 3 given patterns? Pattern 1 has 1 square, pattern 2 has 2 squares, pattern 3 has 3 squares. Now we need to draw pattern 4. So pattern 4 will have how many squares? Yes, 4 squares. This is pattern 4. Now for part B, we need to find the number of sticks. As you can see, in pattern 1 we have 1, 2, 3, 4 sticks. Pattern 1 we have 4 sticks. Pattern 2 we have 1, 2, 3, 4, 5, 6, 7 sticks. Pattern 3, 1, 2, 3, 4 sticks, 5, 6, 7, 8, 9, 10 sticks. So pattern 1 we have 4 sticks, pattern 2 we have 7 sticks, pattern 3 we have 10 sticks. Now you can count for pattern 4, or we can also try to find which operation we have to perform to get the next term. You can see that we are adding 3 to get the next term. So for pattern 4, we are going to have 10 plus 3, 13 sticks. Or you can also check your answer by counting the number of sticks here. Pattern 5 will be 13 plus 3, which is 16. Now let us look at the next example. Consider the following pattern of counters. You have pattern 1, pattern 2 and pattern 3. Complete the table below. So you have a number of a pattern and you need to find the number of counters. So you can see that for pattern 1 we have 1, 2, 3, 4, 5 and 6 counters. Pattern 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 counters. Now for pattern 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have 14 counters. Can you try to find what we are doing to get the next term? 6, 10, 14. Yes, we are adding 4 to get the next term. So in pattern 4, how many counters will we have? 14 plus 4, which is 18. And in pattern 5, we will have 18 plus 4, which is 22. Now we move on to the general term of a sequence. So the general term of a sequence is usually written in terms of n. When n is replaced by a specific value, it will give us a specific term in the sequence. For example, if we replace n by 7, we would get the 7th term. If I replace n by 10, I would obtain the 10th term. The first example. Find the general term for each of the sequences below. So we have 4 different parts here. The solution. Part 1. 4, 8, 12, 16. What do you observe about these numbers? Yes, we are adding 4 to get the next term. Now, this sequence can be written as follows. The first term is 4. The second term is 8. The third one is 12. And the fourth term is 16. So 4 can be written as 4 times 1. 8 can be written as 4 times 2. 12 can be written as 4 times 3. 16 can be written as 4 times 4. What do you observe? Look at the different colors. The first term is 4 times 1. The second term is 4 times 2. The third term is 4 times 3. The fourth term is 4 times 4. So what do you notice? Yes, these two are same. The first term is 1, second term 2, third term 3, and so on. So the nth term will be given by 4 times n, which is 4n. We call this the general term of the sequence. So here, the nth term is 4n, that is, the general term is given by 4n. Second one, 1, 8, 27, 64, and so on. So let us write the sequence again. 1, 8, 27, 64. The first term is 1. The second term is 8. The third term is 27. The fourth term is 64. Do you still remember how these numbers are called? Yes, these are cube numbers. 1 to the cube, 2 to the cube, 3 to the cube, 4 to the cube. So, once again look at the colors. The first term is 1 to the power of 3. Second term, 2 to the power of 3. Third term, 3 power 3. Fourth term, 4 power 3. So can you guess what will be the nth term? Yes, the nth term will be given by n to the power of 3. That is, the general term of the sequence is n cube. Now we move on to the next one. 1, 4, 7, 10, and so on. So we rewrite it. The first term is 1. The second term is 4. The third term is 7. The fourth term is 10. What can you observe here? 1, I'm going to write it as 1. 4 can be written as 1 plus 3 because we are adding 3 to get the next term. 7 can be written as 1 plus 6. 10 can be written as 1 plus 9. I'm trying to rewrite each term in terms of the first one. That's why I have kept the 1. So here, 1 can be rewritten as 1 plus 3 times 0. Remember, 3 times 0 is 0. The next one, the 3, I'm going to write it as 3 times 1. Third term, the 6, I'm going to write it as 3 times 2. And the last one, 9, I write it as 3 times 3. Why I'm trying to write it in terms of 3? Because I mentioned earlier that we are adding 3 to get the next term. This is where I get the 3. You can see that we are adding 3. 1 plus 3, 4. 4 plus 3, 7. 7 plus 3, 10. So I'm trying to rewrite the different terms in terms of 3. 3 times 0, 3 times 1, 3 times 2, 3 times 3. Now, 0 can be written as 1 minus 1. The 1 here can be written as 2 minus 1. The 2 can be written as 3 minus 1. And the last 3 can be written as 4 minus 1. Once again, observe the colors. You can see the first term here. First term, I have 1. Second term, I have 2. Third term, I have 3. Fourth term, I have 4. And you can see in each term of the sequence, we have 1 plus 3 times the term minus 1. So what will be the nth term here? It is going to be 1 plus 3 times n minus 1. I'm just following the pattern that we have obtained here in the last row, and I'm trying to rewrite the nth term of the sequence in the same form. So 1 plus 3 times n minus 1. Because remember, when I had first term, it was 1. Second term, it was 2. Third term, it was 3. So when I have nth term, it's going to be n. Now simplifying, I'm going to get 1 plus 3 times n, which is 3n. 3 times minus 1, which is minus 3. Now 1 minus 3 is minus 2. So the nth term, the general term, will be given by 3n minus 2. Let us have a look at the fourth term. If I replace n by 4, I replace n by 4, 3 times 4 minus 2. 12 minus 2 is 10. And we can see that the fourth term was in fact 10. So this means that our answer is correct. A fourth one, 30, 25, 20, 15. What can you observe in this sequence? You can see that we are subtracting 5 to get the next term. So this sequence can be written as follows. First term, second term, third term, fourth term. 30, I'm going to write it as 30 in terms of a first term. Here, 25 will be written as 30 minus 5. 20 will be written as 30 minus 10. 15 will be written as 30 minus 15. Now, 30, I'm going to write it as 30 plus negative 5 times 0. Why negative 5? Because we are subtracting 5 to get the next term. Minus 5. I have to minus 5 to get the next term. So that's why I have a minus 5. And I always write in terms of the first term, which is 30. The next one, this 5, I can write it as minus 5 times 1. So 30 minus 5 is written as 30 plus minus 5 times 1. In the same way, minus 10 can be written as minus 5 times 2. The minus 15 can be written as minus 5 times 3. Now, the 0 can be written as 1 minus 1. The 1 here can be written as 2 minus 1. the 2 here can be written as 3 minus 1. And the 3 here can be written as 4 minus 1. Why have I done it? Because I want to write the first term in terms of 1 minus 1. So that we can see once again the colors. The first term I have 1. Second term I have 2. Third term I have 3. Fourth term I have 4. You can see that the 30 is going to appear in all the different terms. Minus 5 also will appear. Minus 1 here also will appear. What is changing is this value. 1, 2, 3, 4. So the nth term will be given by 30 minus 5 times n minus 1, because I'm talking about the nth term. So it's going to be n minus 1. Expanding the brackets, I'm going to get 30 minus 5n. Now remember, minus 5 times minus 1. Minus times minus is plus. So I get plus 5. 30 plus 5, which is 35, minus 5n. You can check your answer. Let us try for the fourth term. So here n is going to be 4. 5 times 4 is 20. 35 minus 20 is 15. So the fourth term is 15. This means that our answer is correct. Now we move on to the next example. Patterns are made of sticks as shown in the figures. Part A, draw pattern 5. Part B, complete the table for patterns 4 and 5. Part C, find an expression for the number of sticks n for pattern n. Part D, hence find how many sticks are needed to make pattern 200. Part E, which pattern will have 30 sticks? So let us start. We need to find pattern 4 and 5. You can observe here pattern 1, 2 and 3. I have 1 square, 2 squares, 3 squares. So for pattern 4, I will have 4 squares. Pattern 5, I will have 5 squares with the triangles at the top. Now part B, I need to find the number of sticks. So you can count the number of sticks. Pattern 1, 1, 2, 3, 4, 5, 6, which was already given. So we already have a number of sticks for pattern 1, 2 and 3. Now I need to find the number of sticks for pattern 4 and 5. One way of doing it will be to count the number of sticks, or the second way will be to find the pattern. You can see that we are adding 3 to get the next term. So here 12 plus 3 will be 15. 15 plus 3 will be 18. So this is part B. Now part C. Find an expression for the number of sticks for pattern N. We are going to use the table found in part B. So as you have observed, we added 3 to get the next term. Now I'm going to consider the numbers 6, 9, 12, 15, 18. I'm going to rewrite these numbers in terms of the first one, that is in terms of 6. So this is 6 plus 0, 6 plus 3, 6 plus 6, which is 12, 6 plus 9, and 6 plus 12. Now, the 0 can be written as 3 times 0. Why 3? Because we are adding 3 to get the next term. Here, the 3 can be written as 3 times 1. The 6 can be written as 3 times 2. The 9 can be written as 3 times 3. And the 12 can be written as 3 times 4. The 0, I'm going to rewrite it as 1 minus 1. The 1 here, I rewrite it as 2 minus 1. The 2, I write it as 3 minus 1. The 3 here, I write it as 4 minus 1. And the 4, I write it as 5 minus 1. You can see once again the colors 1, the first pattern number 1 minus 1. Pattern number 2, 2 minus 1. Pattern number 3, 3 minus 1, and so on. So the 6 is going to be constant throughout, plus 3 times. The minus 1 also will stay the same. What is changing is the pattern number. So, for pattern n, we will have 6 plus 3 into n minus 1. Now, expanding the brackets, I'm going to have 6 plus 3n minus 3. And 6 minus 3 will be 3. So, the number of sticks for pattern n is 3n plus 3. Now, part D. Hence, find how many sticks are needed to make pattern 200. So, the number of sticks needed to make pattern n is 3n plus 3. Now, to make pattern 200, it will be 3 times 200 plus 3, which is 603. The last part, which pattern will have 30 sticks? We know that to make pattern n, we need 3n plus 3 sticks. Now I need to find out which pattern will use 30 sticks. In other words, 3n plus 3 will be equal to 30. So I need to find the value of n. 3n will be 30 minus 3, which is 27. And n will be 27 over 3, which is 9. In other words, pattern 9 will use 30 sticks. Now you have some exercises to practice. The first question, first part, find in terms of n the general term for the following sequences. You have parts A, B, C, and D. Hence, write down the 10th term in each of the sequences above. Second part, you have some patterns and you need to complete the table. Part B, given that x equal to 3n plus p, where p is a constant, you need to find the value of p. Part C, find in terms of n an expression for y. Second question, question number 3. Question number 4. Question number 5. So students, in today's lesson, you have learned how to complete number patterns from figures and also how to find the general term of a given pattern. I hope you have enjoyed today's lesson. Until we meet again, it's goodbye.